We are in Algebra 2. We are on lesson 3-2, multiplying polynomials. So some more basic stuff today, maybe getting it a little bit harder. Let's start off with our vocab. A monomial. What is a monomial? What is a monomial? Anyone? It's kind of like a unicycle. Monomial. Andrea, go for it. You're close. One term. So let's come over here. Andrea. This is the wrong class. There's Algebra 2. And there's DXP. Yeah. So a binomial has how many terms? Raise your fingers. Yeah, there it is. It's like a bicycle, binomial, 2 terms. A trinomial, number of fingers, is, yes, you have it correct. It is 3 terms. And polynomial. What does the word poly mean? Yeah, there it is. That's the exact definition. Poly just means many. It's many terms. So polynomial is a general way of saying, hey, that thing kind of looks like a thing. That thing kind of looks like a polynomial. A polynomial refers to both it refers to a monomial, a binomial, a trinomial, a quadnomial. Polynomial refers to all of these things. It means many terms. If you don't know what it is, say it's a polynomial, you'll probably be correct. There's a few things that are not polynomials, like weird fractions, like if you have x in the denominator, that's not a polynomial. But in general, everything is a polynomial, including a monomial, including a binomial. And just to give you an example, a taste of a monomial would be something like xy squared. That's a monomial. A binomial is something that looks like this, xy squared plus 3. Now there's 2 things in there, so that's a binomial. A trinomial will have 3 terms, etc., etc. So polynomial, although the bike says has many wheels, it can have 7 terms, it can have 20 terms, it's still a polynomial, even though the unicycle is also a polynomial. Questions thus far? All right. So, adding versus multiplying. If I add x, x, and x with a quiet raised hand, I get, this is from our warm-up yesterday, Gio. 3x. So when I add 3, the coefficient, and again, if you don't know that word, you should know that word. This is called the coefficient. Coefficient. The coefficient counts how many x's there are when you add. So thank you, Gio.
What? Oh.
And when I multiply, I get what? Eva? X cubed. And now 3 still counts the number of x's, just like 3 counted the number of x's, but instead of having a coefficient, I now have a power. It is to the power of 3. So you're still counting, just the number goes to a different place. And there is a key difference when you're adding polynomials, adding monomials, I guess in this case. These terms, when you add, you have to add like terms, and that was our lesson from yesterday. So our like terms, we have a 5x and a negative 2x to make a, shout it out?
3x.
3x. And then 4y, that does not get combined with the 3x. You don't write 12xy. We have this 4y by itself plus 4y. However, now that we're multiplying, you just squish everything together. It all is one giant mortgage of food. So let's multiply all the numbers first. Here we go. Ready? 4 times 5. 5 times 4 is 20 times negative 2.
Negative 40.
There it is, negative 40. I squished all the numbers together. I multiplied all the numbers together. I'm now going to multiply all of the x's and y's together. X times y times x is with a quiet raised hand. What is that, Andrea? X squared y. There it is. I just squished them all together. That's the key difference. Multiplying, squish them together. You don't care about like terms. Adding, you do care. There are more restrictive rules. It is slightly more segregated. Darn segregation. I want to talk to you about some advanced distribution. So distribution is just another way of saying you're multiplying by a bunch of things. Geo? Yeah, you're still paying attention instead of drawing? Yes. So advanced distribution, I'm going to give you a tool, Chris, for advanced distribution. Advanced multiplication, I should really be calling this thing. And this tool I'm going to call, it has many names. You can call it a rectangle, a box, a table. Eureka Math calls it a table, a tabular tool. So I'm going to be calling it a table. Here is my table. I'm using the tabular method because I have a table here. I'm going to write x squared plus 2x plus 8 right here. Here I go. You're writing with me. X squared, there it is. Plus 2x, there it is, plus 8. I'm also going to be writing x plus 3 on the side. X plus 3. Notice that I keep the sign with it. Even if it's a plus, I write the plus. If it's a minus, you write the minus. This is a tool. You do not have to use it. It is a tool to help you multiply very big polynomials. If you have a quadnomial times a quadnomial, you probably want to do this aside from doing the multiplication like this times this, 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 this times this. It gets confusing. There are too many lines there. So instead of doing all those lines, I have this nice table. What I'm going to do is I'm going to multiply columns by rows, and then I'm just going to add what I have inside this box. Every single 6 of these terms, I'm just going to add them up and be done. Here's our tool in action. Are you guys ready for some mental math? Here we go. X times x squared. X cubed. Again, I took this x squared. So now I'm doing this cell right here. So I'm doing x times 2x, which is, shout it out, 2x squared. What about this one? Quiet raised hand for XP. What goes in that cell, James? 8x. There it is. Thank you, James. We'll give some more XP out here really quick. What goes in this cell? Quiet raised hand. Steph. 3x squared. Thank you, Steph. Stego, I'm going to give the next one to you. 6x. There it is. Thank you. Chris, you do the next one. 11?
Oh, 24.
24. Thank you, Chris.
I thought he was just joking. Yeah, me too.
You never know with that one. He's a jokester.
Yeah, I was a joke.
But he looks so smart over there. Look at that guy. Look at that guy with glasses. He's so smart over there. You can just tell.
This guy or that guy?
James, what are you doing? You're not supposed to be doodling. That wastes the marker.
I'll task.
All right. So I'm not going to write down any of this blue stuff. I wrote the blue stuff on the outside of the table as a way to help me multiply. All the red stuff, I'm going to add those together. Let's find all of the like terms. Let's find all the x cubes. Where are all the x cubes? There's one right there.
There's one.
Oh, there's just one. Okay, so there's our x cube. Let's add all of our x squareds. Oh, there's one right there. Is there any other?
Yeah.
Oh, yeah, there it is. 3x squared. Nice. So those added up, shouted out is?
5x squared.
There it is. Good job, girls. Let's find all of the x's. There's one right there. Oh, look at that. Oh, lag. Look at that. And I hear Stego correctly saying 14x. And finally, let's choose red again. I am left with 24, so that's going to be plus 24. Notice that I chose numbers in the standard form, so I wouldn't have to rewrite it in standard form. So this I'm going to call our table tool. This is a table tool to do hard multiplication. And all we have is one example, nothing on the back. So I want you to try out this tool. If you don't like it, that's okay. You don't have to use it. I am forcing you to use it for example 1. I'm forcing you now to make your own table. Make your own table for example 1. Multiply together on the inside of the table. Find like terms, add them up, write down your answer, box your final answer, which I forgot to do up here, and we'll be back. We're back. Example 1. All right, this is the fastest way to make your table. I noticed that a lot of people were struggling to make the table. Go ahead and just realize this is a trinomial, because there are 3 terms. This is a binomial. I like to put the bigger terms on the top, so I just roughly make a shape. I just say, looks good, right about there. Just start with your box, and then you can label this up above the box. I'm just going to put this polynomial here, this trinomial, 2a squared minus 6a plus 11. I just rewrote this polynomial, this trinomial on the top, and then on the side I'm going to do a squared plus 3. Once you have them written out, then you can divide it up pretty easily. Chunk, 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 like that. All right, here we go. You guys are telling me what to fill in for the area of this table, the area of this rectangle. First cell, Andrea, and then we're just going to kind of snake around. 2a to the 4th. Next, Stego.
Negative 6a to the 3rd.
Eva.
11a squared.
Gio.
6a squared.
Steph.
Negative 18. Chris.
James.
14.
I was joking.
Wait.
All right. Fiona, combine all the a to the 4th terms. What do you get? 2a to the 4th. That's because we have 2a to the 4th. All right. So coming back. Oh, you have a question?
If we're multiplying both of them. No. But I don't know. I was actually.
Go for it, James. Yes.
I'm right. All right. No, let's do that.
You crushed James.
Are you sure, James? I can answer any question that you might have. Don't feel put down by any of your peers. I can answer any question that you have. No? All right, we're going back to Andrea. Andrea, combine all of the a to the 3rd terms.
Just negative 6.
Just this negative 6a cubed. All right. Then D3.
17a squared.
17a squared. So those were my a squared terms.
Yeah, but
All right.
Negative. 6a squared is negative.
6a squared is negative.
Oh my. I got it wrong there.
It's okay. It happens. Everyone makes mistakes. All right, Eva, all the a terms.
It's just negative 18a.
Negative 18a. Gio, all of the constants.
33.
Just the 33. And it's not all on the same line, but it's still there. There it is. All right. Any questions on the notes?
Nope.
All right. So on your summary, go ahead and just briefly explain how a tabular method works, how a table helps you to multiply. It's the same thing as foiling, but a little bit more organized, and it's a little bit easier.